Good morning, grade 9s. Today we're going to be solving a single variable equation in the first degree. So let's start by taking out our worksheets so that we can follow along. To introduce us to today's lesson, we're going to be exploring this problem. A square gymnasium has a perimeter of 20 meters. What is the length needed to cover one of the walls with mirrors? So to help us solve this problem, we're going to be using these goals. First one is to be able to explain the meaning of an equal sign in an equation. The second is to demonstrate how to solve a first degree equation by isolating for a single variable. And the third is to justify both sides of the equal sign are equal to each other. Let's take some time now to complete the skills needed for today's lesson section of our worksheet, and then we'll come back and discuss the answers together. Now that you've had some time to answer all these questions, let's go through the solutions. So the first question was to define an equation, a variable, and a solution. So an equation shows that a statement with two expressions are equal to each other. A variable, we can take a look over here. A variable represents an unknown value, and it always has a coefficient. So we can see that 2 is the coefficient in this case, and a is the variable. And then a solution, the value of the variable that satisfies the statement made by an equation. Now we can ask ourselves, is this an equation? Hopefully the answer you got is no. We know that this is not an equation because this is just an expression that is missing an equal sign, which means it is not equal to anything. Moving on, let's look at this equation. So we can ask ourselves these three questions when looking at this equation. The first question is the number of terms. We can see that there are 4 terms in this equation because they are separated by an addition or a subtraction sign. The 4 terms would be 3x, 2, 3, and negative 5x. So our answer is 4. The second question is how many variables are in this equation. We can see that there's just one variable because the x, even though it's repeated, it's only counting for one unknown variable. 1. And the last question is the number of like terms. We know that there are two like terms. A like term is a term with the same number of variables and raised to the same power, and the coefficients don't have to be the same. So we can see that there are 2 like terms. The last skill that we're going to be using is the 4 mathematical operations. Hopefully you guys already remember these from previous years. So the first one is addition, the second one is subtraction, the third one is multiplication, and the fourth one is division. It is important to know when solving equations in today's lesson that they all have opposite pairs. So the opposite of addition is subtraction, and vice versa, and the opposite of multiplication is division, and vice versa again. It is important to keep in mind all of these skills when solving the problems today.
Now in this part of the lesson, we're going to be learning how to actually solve the equations. What value of x makes both sides of the equation equal? It's important to note some things here before we begin solving. Our variable of interest is x in this situation, but it's not universally x in every equation that we'll be solving for. It could be p, it could be t, a, b, or c. Next, we need to look to see what this equal sign is telling us. And what the equal sign tells us is that the left-hand side is equal to the right-hand side at all times. And what we're going to be doing in this equation is isolating for just x to be able to find that value that makes both sides of the equation equal to each other. The operation being applied to the x is negative 5. So we want to do the opposite of subtracting 5, and we want to add 5 instead because addition is the opposite of subtraction. So I'm going to have x minus 5 plus 5. Now remember, we're maintaining that equality at all times. So we're going to have negative 12 plus 5. Then we simply just collect the like terms on either side of the equation separately. So here, there's only one x. There's nothing like it to collect. So we have x. We can collect these two. We know negative 5 plus 5 is just 0. And then here on this side, it's just the 2 constant terms. Negative 12 plus 5 is negative 7. Now, if we add 0 to our variable of interest, it's neither going to increase or decrease its value. So we know that we'll be left with just x on this side, with our final answer equal to negative 7. Now we need to be asking ourselves is, how do we know that this value, x equals to negative 7, is going to make the left side of the equation equal to the right side of the equation? So to do that, we do something called a check. And to perform the check, you're going to start by simply writing out the original equation. Now we're going to use the value that we solved for, and we're going to substitute it back into the equation. So we got -7 as our answer. We're going to have -7 minus 5 equal to -12. We're going to collect the like terms on either side of the equation. -7 minus 5 gives me -12. And then nothing to collect on the right side. So here I see that my left side is equal to my right side. And I have proven that x equal to -7 is a value that makes this equation true. In our second example, we are told to determine a solution for the below equation. We're trying to find a value for t that's going to make both sides of the equation equal. Variable of interest we're working with in this equation is t, and remembering that the equal sign is telling us that we must maintain equality. When we look at the operations being applied to the variable of interest, some people might see this as one operation or two operations. The one operation would be that t is just being multiplied by 2/3, but the two operations would be that t is being divided by 3 and then being multiplied by 2. We'll look at it as if it's just one operation. T is being multiplied by 2/3. The opposite of multiplying would be dividing. I'm going to have 10 divided by 2/3 also on the right-hand side of the equation. We invert and multiply. So we're going to have 2/3 t multiplied by 3/2. Now I'm going to multiply my fractions out. I'm going to have 6/16 on this side, and I'm going to have 30/2 on this side. 6 divided by 6 will reduce to 1. I'll be left with just t. And on the right side, 30/2 reduces to 15. So doing it where there's just one operation applied to the variable, we see that our answer is t equals to 15. In example 3, we are asked to solve the following equation. We're trying to find a value for our variable of interest that will make the left side equal to the right side. And in this situation, our variable of interest is b, but something that's different from the previous two examples that we've done is that the variable of interest is occurring twice. First thing we're going to do is we're going to expand both sides of the equation out. So, by expanding the equation out, we're going to be able to get closer to collecting like terms and getting that variable of interest to just be occurring once. +6. The variable of interest is occurring twice, but we want it to just be occurring once, so it's easier to find that one unknown value that it's representing. We want to have all of the terms that have the variable of interest on one side of the equation. I have a -2b on this side. And just like before, when I'm trying to get rid of the constant terms that don't belong with the variable of interest, I want to find a way to cancel it out. So to cancel the -2b out on the left side, I'm going to add 2b. So I'm going to have -2b plus 2b. Now, and I'm just going to keep the -12 the same. I'm going to collect like terms. So -2b plus 2b, that becomes 0. There is no other constant term, so 6 remains the same. Now on this side, just so it makes it easier for myself, I'm going to turn this into the 2b into a fraction as well. So I have b over 4 plus 8b over 4. Nothing changes to the -12. Now I can collect the like terms with the variable of interest. So this becomes 9 over 4b minus 12. But first I'm going to choose to get rid of the subtraction. So I would have 6 plus 12 and then 9 over 4b minus 12 plus 12. This is going to become 18 on this side. There's nothing to collect with our variable of interest. I'm going to cancel out the multiplication that's occurring to the variable of interest. So I'm going to divide both sides of my equation by 9 over 4 because that is the opposite of multiplication. I'm going to invert and multiply because that's what you do when you divide by a fraction. I'm going to multiply the fractions out. Now 9 over 4 times 4 over 9, that's going to give me 36 over 36, and that's going to reduce to 1. This will just be b. And this side here can reduce to 8, and this will be b. You get that the answer is b equals to 8.
Okay guys, so now that we've been shown how to solve a single variable equation in the first degree, we'll get you to do some practice questions. If you turn to the practice section on your worksheet, there's a few questions there that you can work on. We'll give you guys some time to work on them, and then we'll come back in a bit to take them up. Okay guys, so now that you've had some time to work on those practice problems, let's quickly take them up together. So in part A, it asked us to solve this equation. The equation was 6 minus x equals 9x minus 14. So like always, we want to identify what our variable of interest is. In this case, it was x. And we see that in this case, x is occurring twice on either side of the equation. So like we said before, we want to collect x to only one side of the equation so that we can simplify and solve for that one unknown value. So we did that in this step, and then from here on, we just performed opposite operations on both sides of the equation so that we maintain our equality, and we ended up getting that x is equal to 2. So for part B, again, we want to identify a variable of interest. In this case, it's t. Our first step in this problem would be to expand fully to get rid of our brackets so that we can fully simplify. So after we do that, we see that t occurs once on either side of the equation. So like in part A, we want to collect all the t's to one side in order for us to simplify and solve for that one unknown value of t. So after we do that, we get to this stage of our problem. And then from here, we're just performing opposite operations on both sides of the equation to maintain our equality, and we end up getting that t is equal to 8. So in part C, our equation is 16 over p is equal to 4. Like always, we're going to identify our variable of interest. In this case, it's p. This might be a little bit different than what we've seen before because our variable of interest is in the denominator. We're not asked to solve for 1 over p, which is what's being represented right now. We're just asked to solve for p. So the easiest way to approach this problem will be to multiply by p on either sides of the equation, again, maintaining equality. And what this does is it cancels p from the denominator on the left-hand side. So by multiplying by p on either side, we'll get that 16 is equal to 4p. And then from here, you just perform your opposite operations to whatever's being applied to p, and you get that p is equal to 4. In part D, we were asked to prove equality is maintained in either A, B, or C. Again, we have to remember that to prove this, we're just plugging in the value that we found for the variable of interest. So in A, it would be 2, in B, it would be 8, and in C, it would be 4, back into the original equations. And after solving, we should get that the left-hand side is equal to the right-hand side. If you guys are having a bit of trouble remembering how to do this, you can just check back at the examples that we did in class. Okay guys, so now that we've gone through our lesson and done a few practice questions on our own, why don't we take a look back at the motivational question for today's lesson, since now we know how to solve it. Okay, so the question asks that a square gymnasium has a perimeter of 20 meters. What is the length needed to cover one of the walls with mirrors? And then it says, recall that the perimeter of a square is p equals 4s. So this is our equation. So our equation is p equals 4s, and we know from our statement that the perimeter is equal to 20 meters. So our first step in this case would be to plug in 20 for p into our equation. So we have 20 equals 4s. So now this is something that we are familiar with, right? So now our next step is just to perform opposite operations of whatever's being applied to the variable of interest. In this case is s. So the only operation being applied is 4, which is being multiplied by s. So the opposite operation of multiplication is division. So we're going to divide by 4 on the right side to maintain our equality. We divide by 4 on the left side. And after simplifying, we get that 5 equals s. So therefore, 5 is the length needed to cover one of the walls with mirrors. To conclude today's lesson, we want to leave you off with how we can extend the knowledge that we've just learned. So what I have behind me is something that we call a system of linear equations. So there are two equations, both in the first degree, which is the type of equations that we've been dealing with today. The only main difference that you'll notice is that each equation has two different unknown variables that we need to solve for. So what I'll leave you off with is that we will definitely need to use what we've learned today in order to solve something like this. We hope you learned a lot today, and thank you for listening.